Hello, and welcome to Unplugged, an IIoT podcast, where we dive deep into the fascinating world of industrial Internet of Things and automation. I'm your host, Phil Seboa. Today, I'm joined by someone with deep roots in industrial systems and a passion for solving complex connectivity problems, Matthew D. Smith. Matthew is the CEO of fieldcloud SaaS, a specialist system integrator based in Greater Grenoble metropolitan area in France. His background spans IT, SCADA, and telecoms, with an early career at Schlumberger before founding fieldcloud in 2009. His mission: solving connectivity problems in complex industrial environments and unlocking value from siloed systems. He's passionate about building sustainable, smart digital operations, and he's even a retro computing enthusiast. Matthew, welcome to the show.
Hey, Phil, thank you very much indeed. So, yeah, great to be a part of your podcast.
It's been an exciting journey. I've been a follower of yours and seen some really cool, technical demonstrations. And look, I've been itching to get you on the show.
Hey, thank you. I tell you what, just two minor corrections to the intro. So, yes, the company is called fieldcloud. The SAS at the end is simply the legal entity denomination here in France. It stands for Société par Action Simplifiée, or a simplified shareholders company. So very similar to PTY Limited in
Right.
Australia or in English-speaking countries. It's that kind of concept. So that's the first one. Second one is my original starting point in my career was actually at Eskom, which is the South African power utility. Back in 1990, I started work doing a sort of a block release program where I was studying and working, alternating 6 months on, 6 months off. So that was the starting point in my career.
Oh, awesome. Maybe you can give us a bit of a background into Eskom and some of the telecommunications background that you came from.
Yeah, no, absolutely. So my original field of study was electrical engineering, heavy current. So power systems, power electronics. I even specialized in metrology and measurement technology. So um, basically, during my studies and work experience, which started in 1990, I literally did the rounds from network planning. So this is typically the engineering team that looks after calculations for how the power grid is and the distribution network is to evolve over time and dimensioned correctly, structured correctly. And I started there, and I ended up finding my way into telecontrol. So this is basically SCADA systems for the power network. So all of the supervisory and operation support that links substations back to a control center, and where the control center is involved in coordinating work that happens in the field where electricians go out and need to perform maintenance. What was particularly curious about that time was that the department that I was assigned to was called PTMC, which stood for Protection, Telecommunications, Metering, and Control. So this literally was the full range of the technology space for everything that again is used to automate substations. So that's protection. Protection is just another way of talking about PLCs that are used in substations. The telecom part is all the connectivity piece, and then metering, that speaks for itself. That's like where, basically consumption gets translated into revenue. Really important, because if you can't bill your customer, you don't have a business. And then the control part is obviously operating the entire system, the entire network. And so I fell into that space, and that got me working with some very old computer systems and communication infrastructure back in the early mid 90s. So between 93, 96, 1997, actually, when I left Eskom. I ended up working with 1970s vintage mini computer and mainframe computer systems. So that, I suppose, got me into retro computing, because in my youth, I was already having to deal with like really old and obsolete technologies that needed to be modernized.
Right. I mean, those kind of systems, you have to blow the dust off them, and but they'll still go forever, right?
Well, even more than blowing the dust off. So the particular mainframe system that was used for the power network telecontrol for the distribution network was running on a redundant pair of PDP-11 computers. So PDP-11s were made by Digital Equipment Corporation company, which ended up being acquired by Compaq, and before Compaq was acquired by Hewlett Packard. But Digital Equipment Corporation had this really amazing like sort of technology, but the memory, the actual RAM, the random access memory, wasn't solid state. It was using ferrite cores, so it was magnetic memory. So as I said, it's like worse than blowing dust off the system. If you go back to high school physics and you think about magnetism and magnets, right? If you are basically magnetizing and then demagnetizing magnets over a period of time, you end up having a hysteresis effect where magnets no longer can be demagnetized by passing electrical current around the magnet. And this is what used to happen. So we had memory parity errors on the
Right.
computer. And I remember going on a call out with a senior tech I was shadowing, and we ended up having to call out a support specialist who was working for a company that supported digital equipment technology, or DEC systems. And this guy comes out and he says, "Oh, no, don't worry. It's easy. It's easy." It was like, "Oh, but this is really bad. We think the memory's failing." He said, "Watch this." And he shuts down the frame. He pulls out this shelf, and there's this like set of ferrite cores. So these are tiny little
Right.
magnets. He pulls this thing out and he drops it on the floor. We're like, "What the hell are you doing? This is like precious stuff, You can't do that." He said, "Watch." And he puts it back in, and sure enough, machine boots up, no parity errors. Now, why is that? Think about when you drop a magnet on the ground, what happens?
Yeah, you
It
get
loses its
disturbance. Yeah,
magnetism. You
that's right.
basically are scattering the alignment of electrons that are inside the magnetic structure inside the iron or ferrite, right? And so that was a lesson I learned, which was like, okay, so there's some weird things you have to do on vintage systems. And I guess that stuck with me throughout my career. So I've always had a slightly different regard to computer technology that's used inside the factory floor or in the field.
Yeah, and we're always kind of talking about that ingrained knowledge, right? And how do you transfer that knowledge, between operators who know where to either drop a mainframe or bang a hammer.
Yeah.
Well, that's kind of an extreme kind of scenario where you have to pull out a rack and, hit it in the right place.
Exactly, because I mean, this is a perfect example of tacit knowledge, right? Or again, something which, you end up from gaining practical experience is second nature to you. And it's not necessarily something that will find its way into a maintenance manual. There's always some interesting reasons why some of this tacit knowledge doesn't actually get formalized or encoded properly. And I think this comes back to, really what drives me today is all very well having a lifetime of experience and building up this great mental sort of body of knowledge, particularly where things are tacit and not explicit. But how do you transmit that? How do you share it? How do you actually prepare the next generation for their own journey, so that not only are they equipped to deal with some of the random stuff that gets thrown at you in operations and maintenance, but also how to build the next wave of tacit knowledge. And I'm of the opinion that no matter how sophisticated we can build LLMs and GPTs, the whole sort of way in which we interface with knowledge today, and having synthetic knowledge delivered by artificial intelligence, no matter how sophisticated we make that, there's always going to be these things that, again, humans can do because of how we create heuristics. All right. So heuristics is a kind of a big word, and I'm not sure if we want to go into the definition of heuristics, but effectively heuristics are mental shortcuts, right?
We're taking the easy route, right? Like the jump between points rather than taking all the every nuance between.
Yeah, correct. I think heuristics is a great way to help humans not overthink things too much, right? So that when we need to react, we can react fast.
Yeah, there's a overheating of the brain, basically.
I, I know how that feels sometimes.
Yeah, absolutely. I guess at your, from your work at fieldcloud, which focuses on connecting and integrating siloed systems, we're talking about a siloed system right here, right now, in that you have to pass on that data, right? I guess you're working in some of the toughest environments. Can you talk us through like some common connectivity challenges that you've faced and you've solved in your experience?
Yeah, I mean, I like to think back to the very first project that Phil Cloud did, and it was an interesting segue between my kind of middle part of my career. I spent 13 years working for the leading oil field services company, Schlumberger, now known as SLB. And the year I left SLB and founded fieldcloud, the first projects that fieldcloud did were very much linked to my previous, role and activity at SLB, which was all about providing what we referred to, in fact, the team was called CSI, Consulting and Systems Integration. It was all about doing special projects and fixing rather complicated challenges that are found in the oil field, where the solution, a mainstream solution, just didn't fit very well. But the very first project that fieldcloud did was in Angola, in the South Atlantic. And it was a project to deploy a data acquisition system. In fact, there were multiple instruments and data acquisition systems that were being deployed. This was at the very early days of what is known as distributed temperature sensing, or DTS, which uses fiber optic and DSPs to calculate a temperature profile. So in other words, a whole matrix of temperature data that comes from measuring backscatter on doped fiber optics. So you shine a laser down fiber, you measure the backscatter, and depending on how the temperature at a particular interval affects the backscatter profile, we're able to calculate temperature. So there was this DTS part. There were also were downhole permanent gauges. So some of the other technology that's used in the oil field uses quartz crystal to basically using a piezoelectric effect to measure pressure and temperature in the well bore. And this is really important when you are working on a brownfield project, brownfield field, redevelopment. So coming to the end of, the original design life for the oil field production, and you need to boost production somehow. So a lot of the ways we boost production in the oil field is to drill new wells and inject either gas or water into these wells, which will then increase the pressure in the rock formation and allow hydrocarbons to flow on the production wells. So this field in offshore Angola had been put into production in the 1980s. It originally belonged to ELF, Aquitaine, which is now part of Total Energies. And part of the agreement with the Angolan state was that at the end of its useful life, ELF would hand it over to the National Petroleum Corporation, who would then take it over and, basically extract or milk out any of the last remaining juice that's underground. So that was kind of like where things were in the sort of around 2008, 2009. There was this project to drill more wells and then add instrumentation in the wells to provide data points that would help production optimization engineers figure out how to set their injection rates on gas lift, basically on injecting gas into the well that would be used to boost production. So all in all, I mean, what was crazy about that project was that again, so you had ancient controls and SCADA on the platform. Again, some of the oldest gear I've ever worked with in I think since I'd worked for Eskom, right? We're talking now about sort of early 80s vintage PLCs, which are manufactured by a French company called April. So the April SMC series PLCs. And I'd like to trot out a few photos I took in Angola of that because they're real museum pieces. So we had those. And then back then, the only way to really deploy some of the data acquisition was to have industrial rack mount PCs. So we ended up having to transport over, and I'll never forget this, right? It was like lugging, 40-kilogram crates of industrial PCs that had been shipped by boats from Luanda, Angola, to this offshore installation, and carrying these crates, basically a pair of us lugging this crate across a gantry, which is called a Widowmaker. All right. So this gantry basically allowed a semi-submersible drilling ship, which was moored alongside the fixed platform, to basically have a walkway. So this gantry was moving, and we're lugging, like, as I say, 40-kilogram crates containing industrial PCs, and then racking them into a rack mount, 19-inch rack mount frame. And I suddenly realized, man, you know what? We could do a hell of a lot better than this, right? How about shrinking the compute that's required so that we could have a more compact system? And so with some of my former colleagues and some of the other technical engineering folks involved in this whole adventure, from an IT service company who was another contractor involved in this, there was this idea to do something better. And that basically gave rise to the very first fieldcloud product, which was called the NS Box. Okay. And so the NS Box was our very first foray into edge computing for the oil field. So instead of having a full-on Intel, Pentium or Core 2 or Xeon-based system running Windows XP or Windows 7, which again was running also like a Windows-based SCADA system. So at that time, we used to use a lot of GE iFix, the old Interlution iFix that was bought by General Electric, which also had its own challenges. You ended up with driver hell and a whole bunch of weird things regarding OPC. And we're like, listen, you know what? This is old school, and we managed to catch this sort of like start of a technology hype cycle, the very early days of OPC UA. So it was like, well, let's go OPC UA. Let's shrink everything down and code it so that it runs under Linux, right? Let's put it onto a small platform. So this box uses a system on chip that's made by Marvell, which was actually had become very popular for network attached storage, so NAS devices. So things like Synology or Buffalo, LinkStation, those were examples of, and in fact, also this same product was used in a number of set-top boxes as well for broadband ISPs. So using that, what made this a good choice was that we were able to then leverage its embedded storage controllers. It had dual SATA controllers built into the silicon. So that meant we could then run redundant, so we actually were able to set up RAID mirrored storage. So have like super robust storage with solid state drives on a box that only consumed like 9 watts of power. And this became important for the next project, which was done in 2011 in Malaysia, where there was a similar requirement to fit data acquisition systems onto a old platform. That old platform was powered by an ancient solar panel system, and the total power budget that was available for everything, including the downhole gauge system, was 50 watts. So I was like, okay, so we need to cram this thing. So we did some calculation, and we literally had headroom of about 10, 12 watts of power for compute. And oh yeah, and the other thing as well is we use satellite communications for that, which was another 25 watts. So in other words, getting everything crammed into 50 watts of power was an interesting exercise. So yeah, just a couple of early examples of how fieldcloud got started and some of the crazy things that weave together consulting and systems integration. So I think what certainly we've learned here in fieldcloud over the last 15 years is that very often there's challenges in expressing requirements and actually figuring out the system sort of like architecture that needs to be communicated to different stakeholders correctly. And so you end up repeating mistakes or having siloed solutions because there hasn't been enough sort of like forward thinking to kind of break up or or break apart the old siloed organization and finding common ground between different domain specialists.
Yeah. Do you have, I guess, being a global, company doing projects all over the world, is languages definitely a barrier there? And I guess you have hard communications with English, talking about these kind of different technology stacks, or how do you, break those cultural challenges?
Yeah, so it's so language can be a challenge, but it's not so much language as it is culture. Um, if I think about kind of like all of the different environments, and the different geographic sort of, regions where fieldcloud has been involved or where our customers work as well, I think the language issue is somewhat secondary to the cultural barriers. There's enough folks out there that speak English as a second language. And as long as you, as a native English speaker, are mindful that sometimes we need to slow down, speak a little bit more clearly, maybe modulate accent a bit, just in order to convey, and then also to tune the ear as well to be familiar with different English accents, or when English is spoken as a second language. I think we're pretty good there. Okay, there's a couple of markets where having fluency in another language is useful, even if it is just the basic vocabulary. And I know from that experience in Angola that, again, having at least a couple of basic phrases in Portuguese nailed down, you're okay. The other crazy thing in Angola, because it's pretty much like borders the Democratic Republic of Congo and the Republic of Congo, depending on where you are in the north of the country, there's a lot of folks that do speak French either as a first or second or third language. So again, for me, French is another important language that'll get you around pretty much everywhere in Africa. That doesn't have English as a first or second language, and it is pretty useful in Europe too.
Yeah, in the Pacific Islands here in our side of the world as well, there's lots of French speaking small islands, which is good.
Yeah, good old Tahiti, French Polynesia.
Yep,
Uh,
exactly. And
for sure.
Numia, and there's a fair few of them around this side of the world.
I think the other, I mean, if I think about other important languages that are out there, I mean, obviously having some command of Spanish is very useful. German is useful. Arabic. So being able to, again, at least get by in the Middle East, is it's important enough to at least know how to say please, thank you, good day, goodbye, right? And ask for some basic things. That's a great way of breaking the ice. And then the rest comes down to culture, right? So, you know, without putting too much emphasis on learning a language, it's about being open to exploring and just being curious about culture, and how culture again finds its way into the workplace, into the professional environment, particularly when it comes to manufacturing operations and field operations. So what's it like between, for example, having to arrange logistics, getting on a truck or a pickup or a 4x4 to go out into the desert, and just kind of basic things like, okay, so how are we going to take a break, right? How are we going to deal with climate differences? And there's a lot you can learn. So I think being able to have that openness and curiosity about culture will go a long way in dealing with language barrier. And probably the best advice I could give to anyone today is go and travel. Actually go and physically experience these places. Get on that plane, get on that boat, get on that helicopter, go take that 4x4, and drive out into the jungle, into the tundra, or into the desert, and you will learn a hell of a lot, and it will leave its mark on you, I think, for the rest of your life.
Look, talking about experiences, I guess maybe you can highlight one of your highlights of your career. Have you seen any particular sites that really interested you, or you thought, wow, that's an amazing application of technology or people or process? Like,
Wow.
does something
I,
come to mind?
I've got a couple of different things, and in fact, it's really tough. You're putting me on the spot here. If I was to pull out one, okay, so I'm going to try and think of a sort of a small best of, right? You really are putting me on the spot, because I must be honest. I've seen some pretty incredible things. I know probably the wildest thing that ever happened to me was when I ended up having to talk about IoT and present a whole thing on IoT to the president of Senegal.
Wow.
So in 2018, I was over in Dakar, Senegal, with one of fieldcloud's clients. We had been working with a satellite telecom operator called Inmarsat. So Inmarsat, which is now part of Viasat, and Inmarsat were working on basically bringing together their mobile satellite services, so a technology known as BGAN, Broadband Global Area Network, and LoRaWAN technologies for IoT communication. And anyway, as part of their whole kind of marketing, or let's say sort of evangelization campaign, Inmarsat had joined a Pan-African organization called Smart Africa, the Smart Africa Alliance. And on the back of that, Phil Cloud was asked to come on board. And one of the reasons for it is because obviously having lived in France for 25 years, I am quite fluent in French, and was asked to basically put together a kind of like a workshop curriculum for a multi-stakeholder sort of like engagement to expose, or to kind of like evangelize IoT device connectivity, and to basically provide some or inspiration and to look at how, basically multiple stakeholders in kind of like in Africa could come together to actually put together useful solutions for society and the economy. So that was kind of interesting. And Senegal was actually the fourth country we did. So the very first series of workshops that we ran was in Niger. So Niger, which is the country just north of Nigeria. So of course Niger is a French-speaking country. So we did Niger, then we did Ivory Coast, so Cote d'Ivoire, and then the third country was Rwanda. And then after Rwanda, we went and did Senegal. But Senegal was wild. Senegal was really wild because, we sort of arrived and ended up meeting up with the hosts, which was the telecom ministry, so the Ministry of Posts and Telecommunications. And we're going through all the logistics. And these guys said like, oh, yeah, hey, cool. So you've got like this workshop that runs over 2 days. And by the way, on the day after you finish the workshop, we have this sort of get together. It's our sort of annual technology forum for economic development with technology, and it's going to be in this convention center. And we'd really like you guys to come and just put together a little booth and showcase the IoT devices and the LoRaWAN stuff and some of the satellite comms gear. And so, okay, cool, no problem. And then our host also said, he said, yeah, and the president of Senegal is going to be giving an address in an auditorium. And there we were thinking, well, that's nice. Unfortunately, we'll probably miss the president's address because we have to man a booth in the exhibition area. Anyway, little did we know that the exhibition was actually for the president. It wasn't actually something that was intended for the general public.
Right.
In fact, it was all set up in a way that when the presidential delegation, right? So there was the president and his entourage of ministers and other dignitaries, right? It was basically to actually have these showcase things that were emerging in Senegal. And of course, the ministry was very keen to position IoT embedded systems, device connectivity as a way of, stimulating some conversation. And it was a very clever play by the ministry to basically put that embed that thing in. But of course, being the only person in the team that spoke French, all right, I was given the task of doing the tete-a-tete, basically the 1 minute, expose and talk with His Excellency Macky Sall, the former president of Senegal. So that was a pretty wild thing, and that's probably one of the craziest things that I have done. I mean, there was another crazy thing where I ended up having to translate between English and French for Inmarsat delegation with the Prime Minister of Niger in the Prime Minister's office, which was like pretty insane. That was like super cool. I'll never forget that. Okay, so those are things that have already kind of kept in my mind. I think that may have also sparked something important regarding fieldcloud's mission. Is that yes, this company works mainly with larger manufacturers and players in the oil field and refining petrochemicals, but also other manufacturing sectors. But part of the mission is also about getting the next generation ready, or again dealing with emerging markets. And so because of that whole experience with the Smart Africa Alliance, with my customer Inmarsat, and the workshops that we put together and co-delivered, right, I actually decided that fieldcloud should become a member of the Smart Africa Alliance. And so fieldcloud joined the Smart Africa Alliance at the end of 2020. And actually, as a follow-up, we did some direct engagement with the government of Ivory Coast to run a follow-up series of workshops on IoT, and we took a bunch of like other embedded technology and ran some fairly meaty boot camps with students and young professionals to kind of like get them into how, the whole thing of like how do you architect, design, and ideate and play with tech to solve real world problems. So that's pretty cool. And I think, if I look at the whole sort of like world today and all of the geopolitical issues that we have right now, I think that there's a lot that can be done across Africa. We just need to stop talking so much and having these high level delegations and conversations where we get senior people together and have a nice lunch and a nice talk and a nice song and dance. It actually needs to get into the real world. I have some fairly strong opinions on that, but that may be a talk for another time.
Maybe. I think like technology and education, right, is hand in hand. If you can get the technology in the hands of the people, they will start to learn about it, right? That's just a natural curiosity, that drives them.
Yeah, and that's only part of the thing, and I think that's where a lot of mistakes have been made, or the system ends up becoming gamed by big tech. So if I look particularly at what has been happening in Africa, which has all been geared around like education, technology, capacity building, right? We call it capacity building. So capacity building, okay. So, all right, we've got to plug a skills gap. We've got to, have a way for, young people to become familiar with certain technology building blocks. But we've got to come back to the bigger societal and economic issue, right? Because the problem today is underemployment or or basically under earning, okay, where there's a lack of economic activity, okay. And so getting kids who are hungry, and I mean, I'm talking about being literally hungry, where one of the ways to bring younger people into these kinds of events is to offer free food, right? So it's like, we'll come learn about, Raspberry Pi, Arduino, LoRaWAN technology, a whole range of different, technology building blocks, right? Or learn about, Microsoft Azure, or learn about, sort of like, you've also got the whole sort of Google community out in Africa as well that are doing things. Microsoft has a huge presence, and a lot of this is geared around, getting kids in, being exposed to technology, and then capturing ideas. Because one thing that I think, in speaking from my own, kind of like childhood growing up in South Africa, is that we're, Africans, we are all full of ideas. We are very aware of problems, and we like to kind of put together DIY solutions. Okay. And so if we can, again, take action on these great ideas, we'll cobble together some kind of solution. It may not be ideal, but it's at least a solution. So
Yeah.
again, when you
Innovation,
so
innovation born out of necessity, right?
Yeah, it is, and doing it in a very frugal way. So now when you throw new tech into the picture, suddenly the art of the possible opens wide up. The jaded and cynical in me sees some big tech corporations out there, which again have a massive dominance in the economy, right? And one of the things that when you become so dominant, you end up becoming quite complacent. And when you're complacent, it means that some of your ability to sort of bring new ideas in and cross fertilize and kind of like find, new angles on things becomes a bit diminished. So the best way to do it is, well, let's throw together some hackathons and some boot camps and some workshops, right? Invite hungry kids in, right? Feed them well, and then let them open up and share their ideas, which again now become our ideas. Because if we look at a lot of hackathon formats that are run, particularly in African countries, there's this transfer of intellectual property clause. So when you sign up and actually attend a hackathon, you're effectively giving a license to whoever's sponsoring it to take those ideas and run with them. So that's, a bit of a challenge. So again, technology, great. Education, great. But again, economic activity and being able to, exchange value correctly, meaning I have skills, I have the ability to translate ideas into action and actually provide a real world solution. Well, I need to be able to exchange that solution with someone who has that problem in a way that there's a fair exchange of value. And that's all based on profit. All right. So how profitable is the exchange of value in a way that it can build, again, robustness in the economy? And that's what's missing. And again, without going into long, dark, deep rabbit hole, looking at all of the issues of why, the economy is gamed in a certain way and where financial systems are set up in a way where, if you do end up making a profit, a lot of that goes into servicing debt. Because money's been borrowed. Effectively, we've been taking money from the future, so future cash flow, and we brought it into the present. We've invented money, we've blocked that, and now we need to pay back with interest. So where the interest payment, that erodes our ability to, again, keep profit and build capital ourselves. There's all these things. And again, this is something we can't go into in a lot of detail on a simple podcast, but there's a lot of complexity there that needs to be, I think, again, dealt with in order to provide long-term, sustainable, truly sustainable economic prosperity.
Yeah, that's a kind of, it's a big conversation, and I think we don't have time for that on this one. But what we do have time is, actually, I want to go into a bit more around your retro computing and some of the, I guess, the cool things. If you're listening to the audio podcast, you don't see the great Windows icon floating around Matthew's shoulder, but he definitely has a passion for retro computing. I guess what's triggered that? I guess your long career using using old tech, I guess.
Yeah, I mean, I go back to my childhood. I was about 10, 11 years old when my dad bought our very first home computer, which was a Sinclair ZX Spectrum.
Nice.
So I started playing around with BASIC as a programming language. And actually, my dad was quite strict. He was like, look, I know you can play some cool games, and I am going to buy some cool games, but you have to write, one program, and then you can have a turn playing games, right? So it was this kind of alternating between actually programming and, figuring out how to actually write some code in BASIC, and the reward was playing the game. And I really, a lot of respect for my old dad who, put that kind of like rule down. I think we broke the rule quite a bit later on, but certainly in the beginning, as a 10, 11-year-old, kind of getting into home computing, that was my starting point. Basically taking out the Specky, plugging it into a good old cathode ray tube TV, and loading files off tape, or basically punching in, basic commands and then saving that onto tape. And that was my true starting point in computing. I kind of stuck with the whole sort of Sinclair world at home until I pretty much was in university and at the beginning of my career. But I've always kept this soft spot for Sinclair, home computers, and I have a collection of ZX Spectrums here. I bring them out. We've even put them on, at trade shows where we've basically bolted on some devices, microcontroller like devices running code that basically allows the Spectrum to tweet, which is pretty cool. So we actually had a ZX Spectrum via a serial. My point was that, so we basically, used the Spectrum connected to a small Arduino compatible microcontroller device that had a LoRaWAN radio on it. And we used that to basically send short messages over LoRaWAN through a base station. And then via that LoRaWAN base station network server, basically call some webhook APIs that would then tweet out a message. So basically, you could get a ZX Spectrum to tweet. And I mean, it was a completely ridiculous demonstrator because you wouldn't actually jump through so many hoops if you were doing this in production. But it was just to show, and I think that's also stuck with fieldcloud's kind of approach, is that just because it's old doesn't mean it's obsolete.
Yeah,
and
absolutely.
That's kind of like a mantra here is, just because it's old doesn't mean it's obsolete. But other retro computing things. So I have a very soft spot for computers that were made by Digital Equipment Corporation. So this is the whole range from PDP 11s, which was the very first kind of like big, kind of like mainframe style computers that I worked with in controls and in the SCADA kind of like, industrial computing space. And then obviously I worked with another range of computers which came out after the PDP 11, which is called VAX. So the VAX systems running a VMS operating system. Digital then brought out the very first commercially available 64-bit microprocessor called the Alpha. And right now, working with a association, basically it's a non-profit here in France, which is called Aconit, which is a conservatory for computing and telematics. And they have this insane collection here in Grenoble of like really old vintage machines. In fact, some of the very, very early examples of French computers, which are not very well known outside of France, strangely enough. But because DEC, or Digital Equipment Corporation, machines were very widely used in both research computing, so the academic environment, government research labs, but also in enterprise, there is quite a big collection of DEC hardware. Digital actually had a factory about an hour's drive from Grenoble, closer to Geneva. And of course, DEC was bought by Compaq. Compaq had a factory an hour's drive from here as well. And Compaq got bought by Hewlett Packard. And Hewlett Packard's European headquarters used to be in Grenoble. They're obviously, their HQ is now in Geneva, Switzerland, but they still have a campus here in Grenoble, and there's a bunch of people that still work on advanced computing here in the Grenoble area. So there's all that kind of like history, but what I'm working on right now is restoring a VMS cluster. So VMS is an operating system that Digital brought out. VMS, interestingly enough, is actually the predecessor of Windows NT.
Wow.
Okay. And it's no secret that VMS, if you just add one character to V to M to S, you get WNT, so Windows NT. And that's a little bit of an in-joke about, why it's called Windows New Technology. But the point of intersection between Microsoft and Digital Equipment Corporation is a certain gentleman called Dave Cutler, who was the architect for VMS and became the architect and senior architect for Windows NT, and joined Microsoft in the late 1980s to work on NT. And so NT, and then again, Windows 2000, Windows, XP, Windows 7, all the way up to Windows 11, a lot of the foundation of the NT kernel and the Win32 APIs and all of the layers that sit above the Windows kernel, all of that is inspired by the pioneering work that Digital Equipment Corporation did to build VMS as an operating system, which is really cool. So restoring this system has been really fun. Yesterday, I was over at Akonita replacing some real-time clock and NVRAM modules on these machines because the batteries had died a long time ago and it wasn't keeping certain NVRAM parameters. That's fixed, and so we've got a system that now boots up. It's terribly slow compared to a modern machine. And we're talking about machines which have 64-bit processors, 384 megabytes of RAM, 1 gigabyte hard drives, SCSI hard drives, and 10 base T or 10 megabit Ethernet. And one of the machines in this cluster actually network boots off a 10 megabit Ethernet network. And so it's like really painful to kind of load the OS image over a 10 meg network using a hub, not even a switch. It's like one of the next steps we're going to do to basically boost a bit of performance is take out the hub and put in a switch and at least eke a little bit better performance by switching, which will be pretty cool. But yeah, it's a lot of fun to kind of like work with that kind of vintage hardware. It makes working with old PC technology so much easier. This machine here, this Windows 2000 screensaver, this is a real machine. This isn't some VM that's running inside a hypervisor. This is real hardware. It's a Pucker Pentium 4 with 1 gigabyte of RAM. It's in an industrial chassis made by Advantech. So we all know Advantech is Advantech do a lot of industrial computing and various gear that's used in the SCADA world or inside the factory floor. But they brought out a whole range of like industrial PC chassis. So these are 19-inch rack mount, and curious about it is it uses a backplane on the chassis, which is based on a peculiar standard called PICMIG or PICMG. And so PICMIG basically allows you to, using a single board computer that plugs into the chassis, bring out both PCI bus and ISA bus. So without going into all the crazy details of old PC hardware technology, this was a way where for industrial applications that used old peripherals, that used the old 8-bit ISA bus to at least have some backwards compatibility with that old world. And today, it's amazing how you still have specialized machines on the factory floor that are clinging onto these old machines and old operating systems simply because the peripherals are critically important for the machine to function. So this PC here has a motion control board inside it, which allows a multi-access motion control system to work. And it's kind of tied to very old software and very old device drivers. These device drivers can't work on Windows 7. They can't work on Windows 10 or Windows 11. So we're kind of stuck in the old world of like Windows 2000/XP.
Yeah. So that's why I guess protocol converters come in and all these different kind of software or even hardware solutions, right? To try and bridge that gap.
For sure. So again, coming back to the mantra, just because it's old doesn't mean it's obsolete. This raises some interesting questions on like, well, all right, so which parts are truly obsolete that need to be thrown out and which parts are worth preserving? To be honest, I haven't been doing a lot until beginning of this year on Windows 2000. It's been a while. I used to live and breathe Windows 2000 25 years ago. So unlike some folks, I do have firsthand experience, but I had to sort of get back into Windows 2000 in a big way for this project. And I must be honest, it's actually a very capable operating system, but it fits into a paradigm of computing that is perceived to be obsolete. So the question is all right, is it really obsolete? Or with the right wrappers, so talking about protocol gateways or proxies, or again, basically
Firewall.
scaffolding that you can put around it. Yeah, firewalls. I mean, it's segmentation. With the right segmentation and the right, wrapping around it, could we still keep Windows 2000 as a relevant core for running some workload that can't be ported, okay, for various reasons? So this is the thing I think that drives a lot of the solutions that we build is you know understanding that inside specialized machines and rather exotic instruments. I mean, I got other examples out there of data acquisition systems and instruments that are still using, for example, Windows CE, right, or Windows XP embedded, or are using embedded microcontroller firmware that, again, has a homebrew network stack that doesn't support all the features in TCP/IP that you need in a modern system. So you have to obviously micro segment the connectivity and then have gateway services that allow you to bridge the old and the new, right? So if you think about Windows uses Windows 2000, right? The way in which you again created applications across a network was to use the component object model, or COM, and something known as DCOM, or distributed component object model, which became a big no-no around 2005, 2006, because it was a major vector for viruses and malware and Trojans and worms that would traverse the internet looking for port 445 being open. So again, how do you bridge that gap, right? And how do you do proxies? And I go back to the old days of, again, tools like Kepware and Matricon OPC, where we used to use OPC DA tunnelers. OPC DA was very much based on COM and DCOM, right? Which is why it only worked in Microsoft environments. So, how do you take that and then, translate protocols into things that are more modern? How do you take something, it's same issue you have, and you guys know this, in modern IIoT systems is, how do you take things that are request response, so where you're pulling data, and turn it into something which can be event driven?
Correct.
Correct. And just because you are, again, specifying, I want everything to be report by exception in my data layer, if you drill down into your automation and controls layer, you may not have the luxury of having native report by exception or native event driven, protocols at that layer, because you're tied to some kind of old device or old instrument, older machine that again has legacy protocols. So I don't see anything wrong, provided you put the right micro segmentation and right micro perimeter strategy in place with gateway services, where I do have some polling request response happening at the lower levels. And as long as I'm able to do that in a way that doesn't enforce that paradigm on my whole system, then I can use my gateway services to deal with report by exception. And you kind of break it up, which, if you think about it, isn't that different to how we designed, or implemented DCSs. If you think about distributed control systems, where you've got polling happening kind of like in a closed loop, and then I've got DCS nodes that are, again, reporting or sharing data back into systems.
Yeah, absolutely. I think, we're still leveraging, those existing legacy systems, right? They're doing, I guess, a great job of keeping those plants running. And I guess maybe as a closing thought, maybe Matthew, is, how can people avoid obsolescence in these types of scenarios then?
So yeah, that is a great question, because that really is what I think the sort of core, of what fieldcloud does and how I believe, my company can help both, end user, organizations, so manufacturers, uh, or machine builders or integrators, like deal with this, right? Is that, again, it comes back to a very simple sort of principle of, there's no need to develop everything in house. Okay, so don't develop everything in house, but at the same time, don't buy everything in from vendors, right? So again, being mindful of the different curves or the different waves in the overall life cycle is to, number one, think about what is evergreen about my enterprise. Okay, and again, settle on a definition of evergreen. What does that really mean? Is my manufacturing business, right, in terms of the actual reason why this company exists, right? Let's say I make consumer goods, right? Okay, am I still going to be making consumer goods 100 years from now, right? you know or is my brand still going to be the brand that I've 10, 20, 50 years from now? And so that allows you to then set sort of like the evergreen, this is the thing that I'm still going to be relevant 100 years from now and be known for, again, making soap, making glue, producing, being an energy provider. Okay, and as long as you've got the right mental picture and vision of like, what is that thing that's evergreen, then you can start looking at your again, your technology life cycle and implementation life cycle waves. There are some things which are very long life cycle, and there are some things which are extremely short. And by, again, aligning that so that you can identify which parts need to be substituted, exchanged, okay, because this is going to inform how you deal with interoperability and interworking. So we know that certain components are going to be short-lived, okay? All right, so that means that they really do need to be independent of some proprietary thing, okay? Or if it is proprietary, okay, what are the consequences of substituting that proprietary thing for another proprietary thing? And making peace with that and saying, okay, well, you know what? This may be complicated, or it may be, again, commercially or contractually a bit, of a burden, but we've at least noted it and we know that those pieces are substitutable. Okay. But I think the error I've seen over the last like 25, 30 years across many industry verticals is that the end user companies have sort of abdicated this responsibility. They've literally said, well, you know what? This kind of thing is non-core to what we do. So we're okay to kind of hand that off to a vendor. And, vendors have definitely also played that card very well. Have said, okay, don't worry, we'll take care of this, transfer that risk to us. Okay. And so you end up sleepwalking into lock-in. And when you have a captive market, you end up with some very unhealthy things in that captive market. And I think that's where we're at right now. So, companies that are, or manufacturers that are forward looking, that are, I think also a lot of it has got to do with like re-examining the balance sheet in these uncertain times, and, looking at the big financial picture. And there are those that are waking up and realizing, okay, we can do it differently. And by embracing that whole principle of knowing what is evergreen and then what is continuously being refreshed and all those things in the middle, aligning life cycle in a way, you can basically, I think, completely eliminate the trauma of obsolescence.
Yeah, that's a really good way of putting it. Yeah.
Yeah, I'm absolutely convinced you can eliminate the trauma of obsolescence. for those who are suffering from obsolescence trauma, I think the best way we can deal with it is by being empathetic to that pain, because it is painful. And I can see, and again, with some of the success stories and some of the projects or engagements that fieldcloud have been involved with, which have not necessarily become truly transformative because of organizational politics, because of fear, particularly fear on the financial side of things, is that I think the best way to approach that is to being that beacon of reassurance, and that, just like, for example, if you are, for example, unfit and need to get back into shape, all right, you're going to need to go on a diet and you're going to need to exercise, and that's going to be painful. You're literally are stepping outside of a comfort zone. So again, embrace that trauma and undergoing trauma now by having to face some very uncomfortable questions about obsolescence. It's like, why did we allow ourselves to be stuck with, for example, machines that are still running a 25-year-old operating system and are missing a bunch of important details in the documentation, or hey, the manufacturer's gone out of business, but we didn't buy the rights to the source code. So, all right, well, to truly deal with obsolescence there, you're going to have to reverse engineer. And so there's a painful exercise, but as long as the long-term objective is that we want to eliminate the trauma long-term, right? This short-term, immediate-term trauma that you have to go through is worth it.
Yeah, absolutely. Matthew, thank you for this, I guess, incredible conversation, diving deep into your past and getting a peek behind the curtain of all those connectivity challenges and the history. I love the retro computing. I will have to ask you, what game was your special treat from your dad? I have to know that.
That's very simple. It was a game written by a guy who shares my name, all right, called Manic Miner. So Manic Miner was written by a guy called Matthew Smith in the UK.
Yeah.
And Manic Miner is the game. That was the game, and that's a game I'll still bring out and play on special occasions.
Awesome. And look, if anyone wants to get hold of Matthew, what's the best place they can reach out to you?
Seriously, the best place is LinkedIn. If you check my profile, there are contact details in my profile, and there's a link where you can actually book a slot to book a call. But there's also a ton of content. So if you would like to sort of figure out who I am, what I do, what my company does, LinkedIn's probably the best place to get started.
Awesome. And so thank you for joining us on this episode. And for all our listeners, don't forget to like and subscribe on your favorite podcast platform. And so thank you for coming on the show, and follow an Unplugged and IoT podcast for more episodes with industry leaders and innovators like Matthew. Thanks for tuning in.
Thank you, Phil.